I'm going to create a new node class. So we're going to show you how to use LinkedList, how to create a linked list on your own here. So first we look at a linked list. Should look like a node here, right? And yeah, we have a node, right? And a node with 2 values, right? So we're gonna create a class name node, right? And we're gonna add the elements on this, and this is a pointer to the next node. Right. So we create a class name node. So this pretty much just represents this node, right? Green box here. And node could have the contents, right? Let's say I'm adding debit, which is, it should belong to this side, right? And this is the contents for the pointer to the next node. So that means I need the attributes name, like string name, or if I want to make it generic. So let's say if I don't make it generic, it's pretty much just like string name. And another one is a pointer to the next node, right? So to the next node, if I just say, hey, this is my next node. And this could be another person on the list, Edward. Okay. And if it's the last item in the list, if we have 2 items, then we pretty much just at the end, this one is going to be null. It's not pointing to anything else, so null, we just do slash like that. Null, right? If we have another elements, we just, instead of null, just make the pointer again, just like the one before. So that means this is a pointer, right? A pointer. So we just say name pointer. And pointer, what's the type? The type should be a node because it's pointing to a node, right? So refer to itself, right? That's the type, right? Cell reference, right? Type. Now we think that if we define this way, we can do set and getters now and constructor, but we can only start string object. We want to support, maybe if I want to change this to number 3, number 4, then we have to refine a new node again, right? Create a new class, and instead of string, it's going to be int. If I do a like account object like bank account or person name user person account, I have to create another one again for node, right? With the account instead of string, so like user account like last time user, which doesn't make sense. That I have to do it every time. Then we just introduced you to what we call generics. So sometimes we see E stand for elements, right? Type. We see T, right? T type. Okay. So this one I'm going to say T type. Like we like to say E when we come to the list, like elements. What element in the list? But this is just the node. So I'm going to say T type. So replacing, it could be any type. So when you use, you just need to parameterize it. The node also is good practice to show it to. Like normally JRE will pick up the type, but you should abbreviate it. It may create an errors, right? Right, to tell it. Now, this node can be any type now. Just when you're instantiating it, just parameterizing it. Like the way that we used to do when we deal with array list, you parameterize like that, right? When you define a node, just give the type. It could be the type that you want. Now, what happens if we do object type? Then it could be any. It could be string, integers, objects mixing in one list. If you just do object instead of specify group, right? So looks like we have the instead of name. Since it's no longer name, it can be any element. Just rename it to relevant to the data that we're going to support, right? Any elements with a pointer. So your node pretty much done. Whenever I create a new node, I just do instantiate this node. So, but we just need to finish it up by giving the constructor. So if a default constructor, that means if a default, the element is going to be empty, right? So no. Pointer is going to be no. You can have the constructor with overloaded constructor. If you want to say, I can pass in the elements, right, when I create it. So this could be like this without a pointer. Then this is going to be element, right? And this is just going to do this dot to say, hey, this refers to the attributes. Or you can have the one with two parameters, right? When we use which this is going to be a pointer, and pointer pretty much is node, right? So now we're ready to do set and getters, right? For all the elements. Okay. Why do we need that? Because when we create a node, we need to set the elements and set the pointer to the next node, right? And set elements, and we want to get to like what's the next node we can get, right? After 3. So that's why I need set and getters for this. And that's pretty much our node. But we didn't create a list yet. We only have one node with all the operations, right? We need to create a list. This is called, this whole thing called linked list, right? So how do we create a linked list here? So linked list pretty much has several nodes in the list. And this is just like array list. You can have operations to it. Right? You can have add elements, remove elements from the list. Now we're going to create a new class then. And this class called linked list. And it's going to be an E now. A generic. It could be any elements, right? Numbers, list of numbers, list of users, list of strings. So what should be the attributes of this then? We know a list should have the node as attributes. So we're going to say node, right? And this node, we need to specify the type, right? When you use the T, so and type is depending on the E here, right? The elements that you provide in. And think about this is going to be a private. Okay, let's make sure that we have all private too. Right. Scope should be private here, and access to the hidden centers. Right. Make encapsulation. So that is the attributes, right? We have to do new, right? Node. We can do in a constructor once we creating the linked list, right? So we're gonna say this linked list without anything. We're gonna say node equals to new node, and it's going to be type. Now, once you create a list, they should have. Right, so we need a pointer to refer to a beginning of the list. I'm calling it LL pointer. So linked list should have LL pointer. So typically, whenever you add something, you actually want to a new node. And this actually, linked list should have just a pointer, right? And that pointer pretty much is pointing to node type. So this is actually should call LL, right? Pointer. The linked list pointer, right? And when you start, the LL pointer should equals to node. Because if you look at this, when I create a first time, I want to generate a linked list. I just say equal to new linked list, right? Linked list equal to linked list. That means I should not have this 3 and 4. I should have just the pointer that pointing to an empty linked list, which is node. Because I don't have any node in the linked list, right? So that is the reason why it should look like this, right? Whenever I create a new node, whenever I create a new linked list, this linked list is a type of node because pointing to the node, right? Then it should be null. That's first time. And then if we want to implement a stat, okay, if I want to implement a stat, then the operation of linked list should be add as a stat. Like I should have the add method, right? So now we're not going to worry about stat yet. Okay? We're going to just make a list, a linked list, to understand how would linked list look like. Linked list should have, when I add a new one, that's called add, right? The method add, which is, it's going to be void add type, and pass in the elements that you want to add, right, to the list. Now thinking about when we add, we probably just create a new node, right? If you look at the image again. So first, this is first when you create. Second, when you start to add a new node. So LL pointer should point to where? Point to the new node. Right. So no longer null because we have something. So here's the new